Slates is represented by orbital frequency of electron. So, what is the frequency is used to the electron can be revolving around in a circular path of a nucleus. So, now we have determined this value means here the angular frequency of electron is omega is equal to 2 pi nu. Already we know this, students. Next, but the relation among the what is the velocity, linear velocity, radius of the orbit, and angular velocity is represented by v is equal to r omega. But omega equal to v by r. This is equation 2. This is equation 1. This is equation 2. From 1 and 2 equations, we get 2 pi nu is equal to v by r. So here we want the frequency of orbit of an electron. So nu equal to v by 2 pi r. So here let us we have to substitute the velocity of an electron revolving in a circular path is represented by v is equal to e square by 2n h epsilon naught. Just now we are determined in a previous topic just now. So let us this is the equation we can assume. So nu equal to v by 2 pi r is the third and this is the fourth. Let us fourth equation substitute in a third equation. We will get the epsilon naught. Here we can multiply e square by 4 pi r n h epsilon naught. So this is equation 5. But the radius of the orbit is r equal to n square h square epsilon naught by pi m e square. This is we are determining first quantity of orbit. So this value substitute in equation 1. So we will r equation 5. We will get the nu is equal to e square by 4 pi n h epsilon. So now let us we can take the frequency of orbit electron. The frequency of an electron which is revolving in a orbit is inversely proportional. We have to determine the frequency of orbit of an electron. Now let us we have to determine the fourth quantity is represented by orbital time period of an electron. Orbital time period, capital T. So already we know the frequency. So frequency nu equal to what is here 1 by t. So this is the main formula. Reciprocal of the time period is called as a frequency. But we can take the what is here time period equal to we can write 1 by nu. For numerator, this is the numerator, this is the denominator goes upward direction. T is equal to 4 epsilon naught square n cube h cube by m e to the power of 4. This is equation 7. This is called time period of an orbit of an electron. So orbital time period of an electron. So here time period of orbital time period of an electron is directly proportional to the n cube. So here what is directly proportional to the n cube, but frequency is inversely proportional to the n cube. So this is the main concepts between the frequency and time period of an orbit in a electron. So now let us we have take the what is here the main important fifth quantity is represented by total energy of an electron. Total energy of electron. How do we can determine the total energy of electron? So the total energy of an electron can be determined by equal to sum of the kinetic energy plus potential energy. What is the total energy of electron? Sum of kinetic energy and potential energy is called as a total energy, that equal to equal to Ke plus Pe. This is the equation 1 is indicates. Then kinetic energy. Okay, let us we have to determine kinetic energy of an electron. So therefore the kinetic energy can be defined as the energy required to due to the what is motion of an electron is called as a kinetic energy of electron. So therefore kinetic energy, okay, we can write in terms of the formula is K is equal to half mv square. Here m is the mass of electron, v is the velocity of an electron. This is equation 2. But the velocity of electron is already determined. V is equal to E square by 2nh epsilon naught. 2nh epsilon naught. This is the equation 3 is indicates. Now substitute the equation 2 in equation 1 we get equation what we have to do, equation 3. So here v value we can substitute. So equation 3 can be substituted in equation 2. We get K is equal to half m into, instead of v square we have to substitute the what is here we can substitute E square by 2nh epsilon naught. So E square by 2nh epsilon naught whole square, that is half into m e to the power of 4 by 4 n square h square epsilon naught square. So therefore m e to the power of 4 by 2 4s are 8 n square h square epsilon naught square. So therefore the kinetic energy of an electron is represented by K is equal to m e to the power of 4 by 8 n square h square epsilon naught square. This is equation 4. As like we have to determine kinetic energy. Then afterwards what we are going to do next, let us we have to determine the potential energy of an electron Pe. The potential energy of electron Pe can be defined as the to virtue of the position of an electron in the electric field of positive nucleus is called as a potential energy. What is the potential energy? The virtue of an object which is having the what is position. Due to position, the energy which is contained the what is here an object is called as a potential energy. So that's why here we can take the what is here, this potential energy will be depends upon the here the radius of the orbit we can take r, and this is the nucleus. Around the nucleus the electron can be revolving circular path. Therefore it will be depends upon the potential. The potential energy can be write V equal to 1 by 4 pi epsilon naught q by r. This is the potential difference between the what is the nucleus and electron. According to this formula, let us we have to write the what is here potential energy or potential in between the nucleus and energy is represented by q is equal to E. We can substitute, then V equal to we can write 1 by 4 pi epsilon naught E by r. This is equation 5. But what is the potential energy? The potential energy is represented by virtue of the position of an electron in a what is the electron field, in a electron field. That's why we can multiply the what is here potential into charge of the electron minus E. So therefore we will get the potential energy. So this is the main important formula of it, potential energy. In this we will substitute equal to 1 by 4 pi epsilon naught E by r into minus E, that equal to 1 by 4 pi epsilon naught minus E square by r. This is the potential energy of an electron. So what is here? So in this is a treated as a equation 6. But according to radius of an orbit is r equal to n square h square epsilon naught by pi m E square. This value is substituted in equation 6. We get potential energy equal to 1 by 4 pi epsilon naught minus E square by n square h square epsilon naught by pi m E square. So here pi m E square is take upward direction. So 1 by 4 pi epsilon naught minus pi m e to the power of 4 by n square h square epsilon naught square. So therefore potential energy of an electron is equal to minus m e to the power of 4 by pi gets cancelled. Okay, minus m e to the power of 4 by 4 n square h square epsilon naught square. This is the equation 7. As like, okay, we have to determine the potential energy and kinetic energy of an electron which is revolving around the nucleus in circular path. So now when we have to determine the both the kinetic energy and potential is determined, okay, now okay, substitute the equations 4 and 7 4 and 7 in okay, equation 1 we get the total energy K is equal to, okay, or total energy E is equal to Ke plus Pe, kinetic energy plus potential energy. So equal to kinetic energy is equal to the mu to the power of 4 by 8 n square h square epsilon naught square plus, okay, potential energy is represented by the minus mu to the power of 4 by 4 n square h square epsilon naught square. Okay, here, okay, we can take the which is the common m e to the power of 4 by 8 n square h square epsilon naught square is, okay, take the common because of in both the terms it is the common. So let us we have take this is a, okay, term is common here 1 by 8 minus plus into minus minus 1 by 4. Now mu to the power of 4 by n square h square epsilon naught square into, okay, here we can take the 8 LCM 1 minus 2 we will get. So that is the mu to the power of 4 by n square h square epsilon naught square into minus 1 by 8. So we can multiply. Therefore the total energy of an electron, okay, is equal to minus m e to the power of 4 by 8 n square h square epsilon naught. This is equation 8. Okay, so this is called total energy of an electron, okay, which is revolving around the nucleus in circular path. Therefore the net energy is, okay, negative because the potential energy, okay, in magnitude greater than the kinetic energy. What is the main condition here? Why we have taken the what is here negative sign? Why it is comes? So therefore the net okay, energy is negative. Net energy is contained negative. Why? Because the potential energy in magnitude is greater than the kinetic energy. This is the main concept here. Thus, or therefore, the negative energy signifies that the electron cannot escape from the atom. Means the electrons can be bounded, or the electrons can be binding. The binding energy is containing, so it will be bound by the nucleus. That's why, okay, it does not escape from the, okay, what is there, atom. So this is the main concept of the, okay, total energy of electron, okay, which is okay, contained in a Bohrs atomic model. The sixth main important, okay, quantity is frequency of the emitted radiation. The radiation is emitting here. When it is emitting, the electron jumps from the higher orbit to lower orbit. Then only it will be, okay, emitted. That's the frequency we have to determine. So the frequency of the emitted radiation can be, okay, found from the following relation. Okay, what is the following relation is consist of the to determination of the frequency. So here, okay, for this purpose let us we have take the what is here the photon energy, the energy between the higher orbit to minus lower orbit energy equal to h nu, photon energy. That's why E2 minus E1 equal to h nu. But here E1 equal to, let us we can assume the what is En1 and E2 equal to En2. Then what happened here? En2 minus En1 equal to h nu. So therefore h nu equal to what we can write? En2 minus En1. This is equation 1. Let us we have to assume. So here, so in this condition, okay, but according to total energy of an electron is equal to minus m e to the power of 4 by 8 n square h square epsilon naught square. This is equation 2. So now in this equation, let us we can assume if n equal to n1, then equal to en1, and if n equal to n2, then equal to en2. Means this is the first orbit, this is the second orbit number we can take. This is the first orbit, okay, energy, and this is the second orbit energy indicates That's why these values substitute the equation 2. We will get the en1 equal to minus m e to the power of 4 by 8 n1 square h square epsilon naught square. This is the equation 3 is indicated, students. And similarly, we can get the en2 is equal to minus m e to the power of 4 by 8 n2 square h square epsilon naught square. This is equation 4th is indicated. See here, only we have to change what is here the number of orbits can be changes here, then the energy also changes. These two are changes, remaining terms are constants. That's why from substitute the equation 3 and 4 3 and 4 in equation 1 we get h nu equal to minus m e to the power of 4 minus m e to the power of 4. So here what we are going to, students, substitute the equation 3 and 4 in equation 1. We get h nu equal to minus m e to the power of 4 by 8 n2 square h square epsilon naught square minus of minus m e to the power of 4 by 8 n1 square h square epsilon naught square. So here minus m e to the power of 4 by 8 epsilon naught square h square n2 square minus into minus plus m e to the power of 4 by 8 epsilon naught square h square n1 square. So in this condition, which is the common? M e to the power of m e to the power of 4 by 8 epsilon naught square h square is the common. This is the So now let us take this common m e to the power of 4 by 8 epsilon square h square. Therefore minus 1 by n2 square plus 1 by n1 square.